want to look at a question in regards to leaving pi for our exact answer. And in this question, we have this napkin ring. And so we want to find out the surface area for just this outer part. In other words, we have to subtract out this inner cylinder, is what's happening. And so when we're doing this, we have basically two surface areas. We have this outer cylinder here and this inner cylinder. And so we need to find the surface area for the outer one and this inner one. Okay? So I'm going to look at this in different ways. I'm going to look at this outer portion as basically a rectangle, okay, because of the fact that if I just look at the sides and I unroll this thing, it's basically a rectangle. So if I look at the outer side, well, the height is going to be 2 centimeters. But here's the thing, it wants me to calculate this in millimeters. So centimeters to millimeters, I literally just multiply by 10. So this is going to be 20 millimeters. So I can change this to 20 millimeters. And I can change this 3 centimeters to 30 millimeters. So my outer portion out here is going to be 20 millimeters high. The radius is going to be 30 plus the 2, because it's got to be the entire thing here. So it's going to be 32. But in order to find its length, we have to take into account that it's a circle. So we have to take 2 times its radius times pi. And so 2 times 32 would be 64. So we have 64, and I just leave pi sitting here. Okay? Now the inner side, its area would still be 20 millimeters tall. And then the length would be 30 millimeters. But then again, I'm going to take 2 pi. So that's going to be 60 pi. So the area of each of these sides, I'm going to take 64 pi times 20, which will give me 1,280 pi millimeters squared. And then where if I take the 60 times the 20, that will give me 1,200 pi millimeters squared. So I found the surface area of the outside and the inside parts of these rings. Now I need to find this area of the top of this ring here. And so if I look at this, the distance from here to here was 30 millimeters. Let me make sure I was correct. Yes, 30 millimeters, and then we had the distance from here to here was 2 millimeters. So basically what we want to do is we want to find the area of the entire circle, and then we want to subtract out this inner circle. Okay? So the area of a circle is equal to the radius squared times pi. And so the entire circle would be 30 plus 2, so 32 squared times pi. So 32 squared would be 1024 pi, and that would be millimeters squared. The area of the inner circle would just be 30 squared pi. So that would be 900 pi millimeters squared. So the area of this little bitty portion here, we would take 1024 pi minus 900 pi, and we would get 124 pi millimeters squared. So that would be the area of this part out here. Now remember that we have a top and a bottom. So we would have 124 pi for the top plus 124 pi for the bottom plus our 1280 pi for the outside plus 1200 pi for the inside. So our total surface area would be 2,728, and I'm just going to leave pi, millimeters squared. When you have a pi in there, it is still a number, but we just leave it multiplied by whatever it is. Now, if for some reason one of these did not include a pi, let's say that we just had a square that did not have a pi or something like that, just like on the previous where we had radicals and I could not combine the radical with the whole number, here I would not be able to combine a pi with the whole number. So let's see, if I had 60 plus 14 pi, I cannot make this 74 pi. I would have to leave this separated because this one does not have a pi. So I have to have like terms, meaning they both have to have pi, or they both have to have a square, the same radical, or things like that. Okay? So let me know if you have any other questions, and I hope this has helped.